Is really easy, but I highly recommend that for these formulas, you guys always write out what the variables are before you start plugging them in. So what are the variables that I would need in order to plug into the formula for the rectangular prism? Okay. So off to the side or margin somewhere, you're gonna write this down. So what would the length be? 12. What would the width be? And the height? The height would be 8, right? So now once you write all the information, it's going to be a lot easier to access the information to plug into the formula. So look at your formula sheet. What's the surface area formula? Okay, so 2 times the length times the width, so that's 12 times 5, which is 60. Then what? 2 times... Okay, so 12 times 8. 96, I think.
Yeah.
And then the last one is 2 times the width times the height, 5 times 8.
40.
Okay, so then you plug that into the formula. Make sure you're writing down your work. If you guys aren't showing me work and you just give me your final answer and it's wrong, you get no partial credit. So show me every single step along the way and I can give you partial credit if you make a slight calculation error. So now you're just going to multiply those together. Tell me what you get.
392.
392? Can anybody confirm that? 392 what?
Centimeters squared.
Centimeters squared. Remember, I'm picky about the units, so make sure you include those. Alright, the volume is equally as simple. The volume is just length times width times height, so you're just going to multiply all of those together. So what would I get if I do that?
40.
Centimeters cubed.
480 centimeters cubed this time because it's a volume. Alright, so rectangular prism, not too bad, right? What do I call the next shape? This is a triangular prism. Now remember, this is really, from the day one, this is the only one that was really that tricky. Anything that involves a triangle, so whether it's a triangular prism or a pyramid or a cone, anything that has a right triangle in it, typically will be a little bit longer to work with because you will probably have to use Pythagorean theorem. So what are the variables that I need for the triangular prism?
Height, base,
The height,
base area,
the area of the base, capital B,
perimeter.
perimeter of the base, P. Is that it?
Yeah.
Yeah, okay. So what is the height of the prism?
6.
12.
It's 12. Remember, we made this distinction. There's a difference between the height of the prism and the height of the triangle. The prism is the whole shape, and remember when you're measuring the height of a prism, it's from base to base. So the distance between this triangular base to that triangular base is the 12. So make sure you're really careful. Whether it's upright or sideways, doesn't change that the height is from base to base. So 12. Now, what would the area of the base be? What shape is the base? It's a triangle. The base is right here, this triangle. How do you find the area of a triangle?
1/2 base times height.
Okay, so I'm going to write this here, and then I'm going to write another equal sign just to remind myself on how I'm doing this. So I need to find the base and the height of the triangle. I need to switch my kind of perspective of this picture to focus just on the triangle right now. So I know that this right here is the base, right? That's 6, and I know that the hypotenuse is 10, but I don't know the height of the triangle. Pythagorean theorem, right? When you're missing one side of a right triangle, use Pythagorean theorem to find it, so you can actually use that information. Question? Yeah.
6 is a, I don't remember, like a multiple of 3.
Okay.
10 times 2 is 5. So wouldn't the other one be 4 because of the triple thing? Or would
Well,
that
the original triple is 3, 4, 5. But if you're multiplying, if they're multiples of 2, then it would be,
that one would be 8.
yeah, it would be 8.
Okay.
Yeah, so you can use a Pythagorean triple, 3, 4, 5. They're all multiplied by 2 to get this relationship here. Or you can just do the Pythagorean theorem to solve it out. But if you do Pythagorean theorem or use the triple shortcut, you would get that the height of the triangle is 8. So then what would the area be? It would be 1/2 times base times height. This height is different. Notice how when I asked for the height of the prism, you have to look at the 12. But when I switch to the height of the base, I'm just zeroing in on just the triangle, not the entire prism. So that's why the height is slightly different here. So it would be 1/2 times 6 times 8. 24. Alright, and then then what would the perimeter of my base be? 8 plus 6 plus 10? 4 again. Okay, so the tricky bit is really off to the side, finding what these variables stand for, actually plugging them into the formula is not that bad. Just remember that you will almost always have to use Pythagorean theorem in one way or another when there's a triangle in the picture. Alright, so the lateral area of a triangular prism is the height times the perimeter. So what would that be? 12 times 24.
288
288
meters squared.
squared. Then the surface area of a triangular prism is that value, the height times the perimeter, plus 2 times capital B. So it's going to be your 288 plus 2 times 24, which is 48. So what's this plus 48? What is it? 36 meters squared. Alright, then the volume is just capital B, the area of the base times the height, so 24 times 12 again. Anybody?
288.
Yeah. So it's the same thing as the lateral area, but it represents something different because we're calling it meters cubed. It's a volume. So you can have the same number for an area and a volume, but they represent different things, and you're indicating that with the different units. Alright, everybody clear with the triangular prism? Okay. I'm going to switch to different types of questions now. We're going to practice the solving backwards. So not only do you need to know how to use these formulas going forward, finding the information and then plugging them into the formulas, I might give you the answer to the formula and ask you to solve backwards for one of the dimensions. So be familiar with these two questions as well. So I'm giving you the volume of a cone, telling you that it's 105 centimeters cubed, and I want you to find x. Now I'm calling this x, but what would we actually call that? Like what would the variable be in the formula?
Height.
Height. So instead of calling it x, I'm actually going to call it h, because that's true to what the formula says in terms of variables. So what you guys want to do is take what they gave you and what shape it's for and write down the formula. So what's the formula for the volume of a cone?
130 pi r squared.
Okay, we're going to write this out. Forget the times h there. We're going to write that out. Then what we're going to do is plug in everything that we know so far into the formula and then solve backwards for what we don't know. Okay? So do I know what the volume is? Okay, so what is the volume? So you're going to type that in, 105, or write it in, not type, 105, and then we have the 1/3 pi, our constant. Do I know what the radius is?
Yes.
Okay, so in the formula I would square that, so what's the radius squared? 25. And then do I know what the height is? No, that's what I don't know, that's the only variable. So now what I'm going to do is I'm going to peel away all the numbers away from h to slowly solve for what that variable is. So what's one thing I could do first?
Divide by 25.
Okay, I can divide by 25, so we can get rid of that. So you can take the 105 and divide it by 25. And give me 4.2. Everything else over here is still there. Then what? I'll just get rid of the 25 part. Notice all of these are being multiplied together, so that's why we're using division to peel them away. So what do I do next? Divide by 1/3, which is the same thing as multiplying times 3, whichever way you guys want to think about it. So if you divide by 1/3 or multiply by 3, you would get 12.6. Now what? Divided by pi. So you're going to take 12.6 divided by pi. Remember to get the pi symbol in the calculator, you would hit second caret, which is the little button underneath clear. You would get 4.01. That's approximately my height. Okay? So it's using the same formula, just a little bit differently. Alright, we're going to do the same kind of thing over here. We have another cone, and they call the dimensions x and y, but let's switch them to what they actually appear, or what the variables actually show up as in the formula. What would y really be? Let's call that h, for height. And what would I call the x?
Isn't that L?
That's L. Remember, L stands for slant height.
The precursor point.
Yeah, and there, you guys, when I was grading the quizzes, I don't understand how this happened, but for some of you guys, you were calling the slant height the height, like in the formula, you were saying, oh, this is h, right? But no, h has to be the vertical one, the straight up and down. The slant height is the one that's slanted. Okay, so you should be able to see that visually in the picture. Alright, so we are given the surface area of a cone, so we're going to write that out. Surface area equals, what's the formula? Surface area of a cone.
Pi r squared plus pi r L.
Alright, excuse me. Alright, so now what?
Plug in everything.
Plug in everything that you have. So I know what the surface area is. I'm going to do this. Right? Do I know what the radius is? It's 2, so if I square that, that would be a 4, right? Plus I to L. Alright, so what variable am I going to be looking for first here? I'm going to be solving for L, and then I can use L in a separate step to help us find H. So I'm going to just focus on L for right now. So how would I do this? There's something I know you guys are going to be tempted to do that's actually incorrect. Yeah?
I have a question.
Sure.
Is it 2m or does m equal 2? For
No, M is for meters, it's the unit.
Oh, okay, never mind.
Okay. Jonathan?
No, I was about to say cancel, but we can.
No, correct. You cannot, there's actually two things I know you guys are going to be tempted to do that you can't. You cannot cancel the pi's out because there isn't a pi on the other side. Okay, so good catch on that one. What's something else that you guys might do that would algebraically be incorrect?
Add 4 and 2.
Yeah, add the 4 and the 2. You cannot add 4 pi and 2 pi together. Why?
We just add.
Because there's an L for this term and not for that. They are not like terms. So you can't just see 4 pi and 2 pi and add them together because this term also has an L. It's just like trying to add 3 and 2x. They're not like terms, okay? So what would I do here? There is something you can do that will make this a little bit easier. I know you said we couldn't cancel out the pi's, but what's something I could do to make this easier for us? Yeah, let's actually do 4 times pi and figure out what it is as a decimal, because I have a decimal over here, so why not turn them into decimals too? So let's go ahead and do that. So I'm going to write this, and then what would 4 pi be as a decimal, just to make it easier?
12.56.
Okay, 12 point, it actually rounds to 57. Now let's do 2 pi as well. 6.28 L. So now that we have it like this, where they're all the same kind of number, they're all decimals, it'll make it a lot easier to work with. So how can I algebraically solve this now?
Just
Subtract this number right here. Subtract the 12.57 away. That leaves us with this value. Then what? Divide by 6.28. Oops, I did not do the right number. So, okay, so it rounds almost exactly to 20. It has 20.0095, blah, 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 blah. We're just going to call it 20. It's close enough to just round it to that.
Could we just wait? No, we couldn't. I was just gonna say for the height, we couldn't round it to 4. No, on the other question.
Oh. No, this one's close enough because it has the second decimal. But this one has 2 zeros before it keeps going. So we're just going to call it 20 for now. Plus, it's going to make it easier to solve for H. So we just found L. Now, how would I use that to solve for H? Pythagorean theorem. So now I have this shape. If you want to redraw it off to the side. I just found that L was 20, and I previously knew that the radius was 2. So I can use Pythagorean theorem to solve. That would be 400 minus 4. I don't know if that's a perfect square or not. Is that a perfect square?
No, I don't think so.
Okay, it's not a perfect square, that means we need to simplify it. So when we are writing our final answer, we get the square root of 96, but I will need to simplify that. So what's the biggest perfect square that goes into that number? I actually don't even know. Is there one? Might not be one. Oh yeah, there is. It's 36. 36 times 11. I doubt you guys would get a number that big when you guys are working through this, but if you do have a radical that can be simplified, go ahead and make sure that you are simplifying it as best as you can. So 6 root 11. Alright? Everybody good up until here? Questions? Alright, moving on to our next two shapes on this page. We have the cylinder and the cone. Alright, what variables do I need for the cylinder?
Height, radius.
Height and radius, that's it. Those are the only two things you need to know. So what's the height of my cylinder?
4 feet.
It's 4. Remember, the height is from base to base, so even though it's on its side, the two bases are circles. So the distance between the two circles, this guy right here, that's the height. What's the radius?
5.
Okay, so write that all down, and then we're going to plug stuff into the formula. So for the lateral area of a cylinder, it's 2 times pi times the radius times the height. This is kind of scratch work I need to see in order to give you guys partial credit if you get the answer incorrect. So what would the final answer be if you write it all together? In terms of pi.
Oh, you have it.
Sorry?
Surface area.
Oh, really? That's odd. Sorry. We're going to start with lateral area. What would it be? Yep. Alright, so you guys, it's like this? That's what it looks like? Sorry, I didn't realize that had happened. Okay, so this would be 40 pi feet squared. Everybody agree with the lateral area? Okay, and then for surface area, it's best to start with lateral area because surface area builds off of lateral area. That's why I guess I forgot to change the order. So surface area is going to be your 2 pi r squared. What's the radius? So then r squared would be 25 plus the 2 pi rh, which we already found in the lateral area, which we already know is 40 pi because we just did that. So then you would have the 50 pi plus 40 pi would give you a total of
90.
90 pi feet squared. That's your surface area. Then your volume is pi r squared times h, 25 times 4.
100 pi feet cubed.
Okay. Alright, so once you know the radius and the height, just make sure you're carefully identifying those from the picture, then you guys can plug them in really easily. What's something else they could do about the picture that might trip you up? This one's really straightforward. What's something they could do to make it a little bit more tricky? We have to be super careful. Yeah, they give you the diameter instead. If they had gone like this and said that's 10, would you use 10 in the formulas? No, you have to make sure that you're checking to see did they give me the diameter or the radius and make sure you're really careful in how you work with that. Alright, in a cone, what are the variables that I'm using? Look at your formula sheet. What are the variables I need to know?
Radius.
Radius?
And length.
Nope. Slant height, that's what L stands for. And then the regular height, which is vertical. So you know the difference between H and L, the slant height and the vertical height. Alright, what's the radius?
7.
7. What's the slant height?
14.
14. What is my regular height?
Unknown.
Unknown. How do I find that?
Pythagorean theorem.
Pythagorean theorem. Remember, for a pyramid or a cone with that triangle that's inside of the shape, you guys will know one of the two heights, the slant or the vertical. They're not going to give you both. So we're going to use Pythagorean theorem to find the H. You can go ahead and turn this into a decimal. You guys are using Pythagorean theorem as a middle step towards the ultimate final answer. You guys can turn that into a decimal unless instructions say otherwise. So if you guys do Pythagorean theorem, what do you get as the height? 1 decimal.
12.12.
12.1. We're just going to use 1 decimal point for Pythagorean theorem. Okay? So now we have all the variables. Now we're just going to plug them in. So are these in the wrong order again? Okay. I'm still going to solve for lateral area first. Okay, so for the lateral area of a cone, that's going to be pi RL. Pi times the radius times the slant height. So we have 7 times 14. Anybody tell me what that result is?
98 pi.
98.
Squared.
98 pi inches squared. Everybody with me on that one? Okay. Now we can switch to the surface area. So surface area is going to be pi r squared plus that pi RL thing that we already found. So I like to do surface area second because it's based on the lateral area. So I wrote the 49 there because it's 7 squared, the radius is 7. So if you add those together, what do you get? $147. What?
Pi inches squared.
Yep. Alright, everybody clear on that one? Lastly, we'll talk about the volume. So volume for a cone is going to be 1/3 pi times the radius squared times the vertical height. This is why you guys need to know h because it comes into play for the volume. So we had to find h in order to plug it into that part. You guys have to be really careful with this one. When you're plugging the numbers in, make sure you put the 1/3 in parentheses. So you want to do 1/3 in parentheses times 49 times 12.1. You'll probably get another decimal back. Double check. Yep, so what is your volume? You guys should get 197.6 approximately. Okay? Inches, what's different? What's different about the volume units? Cube. Make sure you're really mindful about that. Alright, any questions on the first page? Great. Next up we have our pyramid and our sphere. Remember that you guys will have to have the hemisphere formulas memorized, so the only ones that are not on here are the hemisphere, so make sure you do have those memorized still. So we're going to start with our square pyramid, and then our sphere, and then we're going to talk about some other types of questions that we saw in the team as well. So what are the variables I need for a pyramid?
Base, height,
What
and
about
lateral
base?
area.
This area.
Okay, so capital B base area. What else? H height,
Perimeter,
the perimeter of the base, okay, and L slant height. We have 4 things. Alright, so the area of the base, what shape is the base? It's a square, so the adjacent sides are the same, so that means that it's going to be a square. So what would the area of a square be in this case? It would be 144. So the only bases that you guys really need to worry about when you have the capital B show up, the capital B shows up in the triangular prism where the base is a triangle. The capital B also shows up here where the base will be a square or a rectangle. So just remember how to find those different areas. What's the height?
15.
Remember, h is vertical height, so that's what this is pointing to, 15. What's the perimeter of the base?
We don't need. Perimeter 48.
It would be 48 because the perimeter is a square again, so you have 12 plus 12 plus 12 plus 12, so 4 12s is 48. Now the slant height, do I know what that is? Now slant height, if you want to draw it, is along the edge of the pyramid. You have that triangle side that's leaning. The slant height is how long that triangle is, or the height of this slanted triangle. So you guys can kind of see we have a right triangle. Just like I said, it'll always show up in a cone or a pyramid. You have that right triangle. They're going to give you one of the heights. This time they give us the vertical height. We don't know what the slant height is. So I think it's a really good idea to draw this triangle off to the side. We knew that the height, the vertical one, is 15. That's what they told us. This is what I don't know. That's L. So we're going to be solving for. What would I call that other third side? What would I label it as? What number would I use to figure it out? I would use the 12 to help me figure it out, but would I actually write 12? No, it's 6. 12 is the entire length of the pyramid, but the height is coming down to go straight to the center of the pyramid. So from the center out to create this side of the triangle, it's only half. It's going from the center out. So because the full length is 12, I only want half of that 6 to get that side right there. So how would I solve for L, slant height? What method? here. So 15 squared plus 6 squared is equal to L squared. Because this is a middle step towards a different answer, you guys can just give it to me as a decimal. So 15 squared plus 36 should be 16.2 rounded. Yes? So everybody else got? Okay. So now I have all the information. Once you have all that, just plug it into the formulas real easy. I'm assuming these are in backwards order again, but we're going to find lateral area first anyway. So the lateral area is 1/2 times the slant height, which is 16.2, we just found that, times the perimeter, which is 48. Let's go ahead and multiply those, carefully putting the 1/2 the fraction in parentheses, or calling it 0.5 if you want to. $388.8
Yeah.
centimeters squared. Sorry. That's lateral area for you guys who don't know space. That's the lateral area. So I'll put that one first. Makes surface area easier. So surface area of a pyramid is going to be that same value that we just found, the 1/2 slant height times perimeter plus the area of the base. So what would that result be? Henry, do you have that number? Do you have that number? What is it? Okay. Centimeters squared. And then our last one is the volume. The volume of a pyramid is 1/3 times the area of the base, which is 144, times the height, which is the 15, the vertical height, h. So you get those numbers, put the 1/3 in parentheses really carefully, then type it in.
720 centimeters cubed, I think.
Yep, 720 centimeters cubed. Alright, so again, for the triangular prism, the cone, the pyramid, anything that has a triangle kind of built into the shape, you will have to use Pythagoras theorem to help you out, so make sure you don't forget that. Alright, our last shape we're going to focus on is the sphere. So what's the only thing I need to know about the sphere?
The
Radius, which would be 1.4. So we have two formulas we're going to focus on here, the surface area and the volume. The surface area of a sphere is 4 pi r squared. It's going to be a little bit awkward because the radius is a decimal, but that's okay. So you're just going to do 4 times the 1.4 squared. You're going to get, oops, I did subtraction, that's not what I wanted.
7.84.
Yes. 7.84, don't forget the pi. Making sure that you always give the answer in terms of pi unless the directions say otherwise. And then our volume would be 4/3 pi, finish it for me, r cubed. This is the only one, as well as the volume of a hemisphere, that involves r cubed. It has a cube actually in the formula, so don't forget that. This is going to be 1.4 cubed. Big difference. If you don't remember how to cube in your calculator, you would do the 4/3 in parentheses, then you do 1.4, and then the little caret button that looks like this underneath clear, you would push that, and then 3. Unless you have the fancy calculators, I kind of do it for you. So you should get approximately 3.66 if you round. Here's cubed. Okay? Now, just a really quick refresher. What is the formula for the lateral area of a hemisphere? It's on the formula sheet. It needs to be memorized. Lateral area of a hemisphere. Anybody remember? Lateral area? 2 pi r squared. Surface area of the hemisphere? 3 pi r squared. Volume of the hemisphere? 2/3 pi r cubed. So it goes 2/3 for the lateral area and surface area goes 2/3. The surface area, see how it's 4 for a sphere? So it goes 2, 3, and then 4 for full sphere. And then the volume of a hemisphere is just half of the volume of a regular sphere, or full sphere. Okay, so do make sure you have all 3 of the hemisphere formulas memorized before we get into that test. Alright, now the last thing we're going to do with our formula primarily is talking about the compound shapes. We talked about these on day 2, I believe. This is where you have 2 of the shapes that we've talked about and merge them together. We talked about how to find the volume and the surface area of these. Do you guys remember what's different about how you think about the surface area? Because for volume, it's really easy. You just find the volume of one, find the volume of the other, and you add them together. Just like 2 questions in one. But what do you have to do differently when asked for the surface area of something like this?
Don't you not want to put in the part that's covered by another shape?
Right. You don't. If you did the surface area of one, the surface area of the other, and added them, that would double count the circle that's inside the shape, right? Surface area is only supposed to be at what's on the outside. So what do you guys have to do instead? You guys remember? You do lateral areas. You do the lateral area, and then if you have an extra little base on the bottom, you can add that on at the end. So when I ask for the surface area of a compound figure, you have to make sure you switch your thinking to lateral areas of everything, plus plugging any holes on the bottom. There won't always be an extra base that you would need, like in an ice cream cone. You won't need to add an extra base. Just make sure you're paying attention to that kind of idea. But for this question, I'm only asking for the volume. Just wanted to review the surface area thing so you guys have that fresh in your mind. All right, so we're going to find 2 volumes and then add them together. I'm going to draw 2 little arrows, show that we have 2 separate things we're working with. So what shape is on top? Hemisphere. So we just talked about those. What's the formula for the volume of a hemisphere? 1/3? 4/3 is for a full sphere. It's 2/3. 2/3 pi r cubed. What's the radius? 3. So I'm going to do 3 cubed, which it's 3 times 3 times 3, which is 27. So it's 2/3 pi times 27. So multiply the 2/3 and the 27 together. So the first volume, that's not the final answer. That's not the final answer. That's only the volume of the hemisphere. Now I'm going to find the volume of the cylinder so I can add them together to get my final answer, which is the volume of the entire shape. So for the cylinder, what's the formula for the volume? Pi r squared. What's the height of the cylinder? 7. So the radius of the hemisphere and the cylinder are the same. They share the same radius. So it's pi r squared h, so 9 times 7. So if you multiply those, what do you get? Okay, 63 pi. So I have the, add them. So I have the 18 from the hemisphere and the 63 from the cylinder. Add them together, what do you get? 81. So it would be 81 pi inches cubed is my final answer. So when you have a compound solid, make sure you find the information for both of the shapes separately, whether it's volume or if I ask for a surface area, you're going to find the lateral areas, and then add them together. Alright, lastly, I want you guys to try this word problem on your own. I'm describing a shape instead of giving you a picture. It is a pyramid that has a square base. If you want to draw it, you can. I give you the one that's hardest to draw. But if you want to try to draw it, feel free. So it's a pyramid with a square base. Each side of the base is 16 meters. Notice it's a square and each side is 16, so you have 4 16s. And then the height, the vertical height, is 27. If I don't say slant height, if I just say height, I'm referring to the vertical one. Okay, so the height is 27. I want you to find the volume. So go ahead and see if you guys can figure that out. Use your formula sheet. I'm asking for the volume. See if you can. You don't need to draw it. You can if you want to. You don't need to. See if you guys can figure that one out. what the answer would be?
Isn't it?
2,304.
Okay, I have 2,304. Any other suggestions?
I got the same.
Every single person here got 2,304. Everybody got something different? You got the same thing? Okay, well, I think that is correct. So you should get 2,304, although, did I not give any units?
No.
Oh, I did, meters. I accidentally left it off there, but it would be meters cubed. Right? The only thing that you need in order to find the volume of a pyramid is how tall it is, the vertical height, and what the area of the base is, because I told you it's square and each side 16, you do 16 squared to find that. Okay? So you don't even need to see a picture sometimes. Alright, now we're going to switch from just straightforward application of the formulas to what we talked about on day 3. Remember, day 3 is where we talked about that staircase. Remember where we go between the dimensions, like Dr. Strange, right? So we're going to talk about that kind of information and how we can work with those questions just like we did on day 3. So this first one here, we have two similar spheres. You don't have to draw them, but you can if you want to. We have two similar spheres where their radii are in a scale factor of 3 to 4. I want to find the ratios of their surface areas and their volumes. Now I don't know what the surface areas or the volumes are, and I cannot find them. I do not know what the actual radii are, I just know what their relationship is. So this is not something where you would try to actually use the formulas and figure out what they are and then write a relationship. This is using the staircase, okay? So if I say that they have a scale factor of blank, what dimension am I in? Scale factor is in the first dimension. Scale factor is in the first dimension. What dimension is surface area in? The second dimension. So in the first dimension, my relationship is 3 to 4. How do I go from the first dimension to the second dimension to get the relationship between their surface areas?
Square.
You square. To go up a step from first to second, you're going to square. So what happens when I square 3 over 4? Not a fraction. Or sorry, not a decimal, it needs to be a fraction.
You get 9 over 16.
9 over 16. You just square 3, you square 4, it's 9 to 16. You can either write it as the colon format or a fraction, I don't really care. Now, what dimension is the volume in? It's in the third dimension. How do you go from the first step? Remember, there is no way to go from the second to the third, so you always use your first dimension as your reference. How do you go from the first dimension to the third dimension? You cube. So if I start with 3 to 4 and then I cube that, what's 3 cubed? It's 27. And then what's 4 cubed? 4 times 4 times 4. 64. Right, remember your basis always has to be the first dimension. You can't go from the second to the third. So just make sure you're always starting at your foundation here. Alright, so everybody clear on how to approach that kind of question? Figure out what dimension you're in and then figure out how to go up or down the steps depending on what the person's asking. Okay? Alright, number 12 says cylinder A has a volume of 100 and cylinder B has a volume of 800. What is the ratio of their heights and their surface areas? Notice it hasn't told me what their heights are. It hasn't told me what their surface areas are, so I can't just write them as a fraction and go from there. What do I know?
Their volume.
I know their volume. So what dimension am I in?
Third.
I'm in the third dimension. So right now I'm in the third dimension. I have a relationship 100 to 800. Is this simplified?
No.
No. So this would not be the relationship. This is just what their formulas are. Sorry, what their volumes are. How would I actually write that as a relationship? The appropriate.
1 over 8.
It would be 1 over 8. So when they give you values like that, go ahead and simplify it as much as you can. So the volumes were in fact 100 and 800, but their relationship simplifies down to 1 over 8. Alright, so this is my third dimension. I want to know their height and their surface area ratios. What dimension is height? This is first dimension, because that height is just one dimension. They only give you one dimension, one radius, one height, one slant height. If it's just one dimension, it's the first dimension. So how do I go from the third dimension to the first? This is going down the steps. Cube root. In the third dimension, everything's cubed. If I'm going down to the first dimension, I'm going to undo that. I'm going to cube root. So what's the cube root of both of these numbers? What's the cube root of 1? 1. What's the cube root of 8? It's 2. If you guys don't remember to do the cube root of something, it's math option 4. Okay? Now, I also want to know what their surface area ratio would be, what the relationship is between their surface areas. I cannot find them using the formulas because I don't know what the actual height is or what the slant height is. Well, this is a cylinder. I don't know what the height or the radius are. Okay? So, how would I find that? Square root this? No. There's no way to go from the third step to the second step, either going up or down. There's no way you can do that. What's the only way that you can get to the second step? Through the first step. So that's why I did this first. So now how do I go from the first step to the second? Square. So if the scale factor, my first dimension was 1 to 2, what's my second dimension? 1, 2, 4. So remember, the staircase looked like this, right? You can go from the first to the second or the third step, but there is no way that you can go between the second and the third. So I just have to either go straight down or straight up. So make sure you guys aren't trying to do something that you can't do between the third and the second dimension. Okay, everybody clear on those two? Last one for this page. Alright, so a red ball has a volume of 100 pi millimeters cubed. Another ball, which is blue, has a radius that is 3 times the radius of the red ball, and they want to know what the volume of the blue one would be. Okay. Did they tell us what the actual radius is for either of these two shapes? So can I just plug in the radius to the volume formula to find this? No. This is a relationship question where you're changing a dimension and seeing what happens with the formula to see what the change would be, right? So we know we have one, well, first of all, what shape is a ball officially? A sphere. And what about the sphere are we working with? Volume. So can somebody tell me, since we're talking about the volume of a sphere, let's just write down what we know about that. What is the formula? 4/3 r cubed. So this is our formula for the volume. Again, I don't know what the radius is for either of these, so I can't just plug it in to find the answer. What do I know about the radius? It's 3 times bigger than the other one. So what would I do? Do you guys remember? I don't know what the radius actually is, but I know it's 3 times bigger. How would I write it? 3r. Right? You change the formula to match what's happening. If the radius is 3 times bigger, then instead of writing r, I'd write 3 times r, 3r. And then remember, we need to neaten it up a little bit. I can distribute that power. There's no subtraction or addition. So what's 3 cubed when I distribute? 27. Alright, so what's the only difference between our new formula for the blue ball and our original for the red? 27 times bigger. So if the original volume of our smaller sphere was 100 pi, and this one's 27 times bigger, what would the new volume be? Don't overthink it. It started here. This one's 27 times bigger. Multiply that times 27. There you go. Okay, you don't need to know what the radius is exactly. You just need to know what the relationship is, what's changing, and you adjust the formula, and then you see how much bigger or smaller it is, and you multiply that times the original volume. Okay? So I'm manipulating the formula. Alright, last page. Oh, alright. I really like this question. It's quite interesting. We have a company that's trying to save money by packaging their products in a smaller container. The original container is a cylinder with a radius of 5 and a height of 15. I just want to make sure this is visual for you guys, so I'm going to draw this. So, it had a radius of 5 and a height of 15. This is their original design. What would the dimensions of a new cylindrical container be if the company wanted the volume to be a third of the original? We're trying to decrease the volume by a factor of 1/3. Okay? we have these options. Whether we want to divide the radius by 3 and just keep the height from changing, keep the radius the same and divide the height in 2, or keep the radius the same and divide the height by 3. Okay, we have to figure out which one of these would give us a volume that is 1/3 as big. So this is actually going to be the same idea as the question we were just working with. Okay, can somebody tell me what the volume of a cylinder is? The formula.
Pi r squared h.
Pi r squared h. I want this formula to be 1/3 as big. Instead of being pi r squared h, I want it to be 1/3 pi r squared h. So what do you think, which variable would I have to change in order to get that? And how? Let's think about it. This first option, they want us to take the radius and divide it by 3. That might be tempting because you can see, oh, I'm trying to make the volume 1/3 as big, so maybe if I just chop the radius and divide that by 3, maybe it'll make the volume divided by 3, right? Well, let's see what happens. If I do that, if I do 1/3 times the radius, like this, what does my formula turn into when I distribute?
Square.
You'd have to square it. It would turn into 1/9 r squared h. Is that the change that I wanted? No. So I can't chop the radius by 1/3. That one's out. Can't do that. Alright. The second change that they're suggesting is that we leave the radius alone, but then what do we do to the height? Split it in half. So that would be pi r squared unchanged and then 1/2 h. Is that the change I want? No, that's not what I wanted. I want it to be 1/3. That only changes it by 1/2. Okay? So that one's out. So obviously by process of elimination that leaves us with C, but let's understand why that's true. What did I do to the height? I divided it by 3. So then I do that adjustment where I leave the radius alone, and then I do 1/3 h. That's how I get the 1/3 to show up, and nothing else changes. Okay, so it's the same idea as the previous question. We're just seeing how different changes, whether it's the radius or the height, how that can really affect the volume. Okay? Make sure you're able to work through that kind of question as well. Alright. Last one before we go into the transformation review. 2 similar cones are shown. I want to know what the surface area of the smaller cone would be. Now normally when I ask for the surface area of something, don't I give you all the dimensions and you plug it in and blah blah blah? That's normally how we do that. Have I given you any of the dimensions besides the radius and the slant height of the big shape? Do I know, well, first of all, let's write down what the surface area formula is. We may or may not need it, but let's just write it down. What's the surface area of a cone? Okay, so I need the radius and the slant height, both of those 2 things for the smaller cone. Do I have both of those 2 things? No, I only have the radius. So, is there a way I can possibly find that slant height?
So, since you know both of them can understand, right?
Yes.
You just put them into a fraction, so you do, well, you know the radius, so just put the whole thing, so double it, so it's 24.
No, you would not double it. There's no point in doing that.
And then you do 12 over 9, and then you do 14 over it.
Okay. How about L? Since that's what we're looking for, right? So because these are similar, make sure you're looking out for that. Because these are similar cones, we can use our proportion. Remember that the dimensions are proportional for similar figures, even whether 3D or 2D. So I can use cross multiplication. I don't know if that has 14. And then divide by 12, 10.5. So this one is going to be using the formula. The only trick is that we didn't know everything up front. So if I give you similar figures and you don't know all the information you would need to plug into the formula, you just use a proportion to figure out what it is you're missing, because you know that they're similar, and then you can plug them into the formula. So for my surface area, it would be pi times 81 plus pi times 9 times 10.5. plug in everything that we know now. So 81, well, the 9 times 10.5. Because these are like terms, they both have the pi, you can add the 81 and the 94.5 together. Did I give a unit? Okay, thanks. That would be your final answer. Okay, so for this kind of question, use your proportions. So that's the Unit 10 material. Anybody have any questions on any of that? Lesson 1 through 3? Alright, really quickly we're going to talk about, again, because transformations are going to be on this test, so let's review transformations again really quick. There are 2 different types of questions I'll ask you. I'll give you pictures and you have to tell me what transformation took place, and then I'll have ones down here where I actually ask you to do a transformation. So first of all, let's see. The black one on the screen was the pre-image and the blue is the after the image because you can see the little primes here. So what happened to go from here to here? Spun is not our word. Nope. It went. No. I want the transformation, the official vocabulary. Rotate, okay. It rotated. Don't just say rotate, you have to tell me how. What direction, how much. Give me the details.
180 degrees.
180. And you can either write clockwise or counterclockwise, it really doesn't matter. It's going to get you in the same position. Okay? And you can physically turn your paper to see what's going on. If you're trying to verify the rotation, feel free to do that. This is rotate 180, either clockwise or counterclockwise. Okay? What about this next one? Again, from black to blue, what happened?
It looks like it was reflected across something.
No, it did not. So for a reflection, the easiest way to tell it's a reflection, see how P is right here? If it reflected, it would be on the other side of the shape. So again, they should be mirror images flipped over, so make sure you're really careful with that. What transformation would get the blue shape to appear from the black? It's translate. If it's the same orientation, you just slid it somewhere. That's translate. Again, you gotta give me the details. How? How much? Which way? Pick 2 reference points. You have your original P and your P prime. Where it ended up how?
Isn't it up 1 to the right? Up 2 to the right 1.
Okay, so you can say up to right 1. That would be true for any of the points, but you can just pick 2 reference points to see what the change was, and that'll tell you what your translation is. Okay? What about the last one?
That's reflected.
That is a reflection. Again, you have to tell me how. So for a reflection, you're going to tell me what did it reflect over? Where's the mirror? Where's the line of reflection?
The X.
The x-axis, right here. You can physically draw that line right through the middle where that kind of fold is that you can envision. That's going to be your line of reflection. So you're say reflection over, and then you would tell me what that line is. Now, remember we talked about this on that day where we were reviewing this. There are all sorts of different lines that you can reflect over. You can have horizontals. If you have a horizontal line, should it be x equals or y equals? Horizontal. This is horizontal. This should be y equals. If it's a vertical line of reflection, it should be x equals. So make sure you're really careful with that. What about the diagonal ones? What are the 2 diagonal lines that you guys could reflect over? Y equals x, or it always starts with y. Y equals x, or y equals negative x. If you do not remember how to reflect over those or how to recognize what those look like, you need to go back in your notes and review that. There are 2 rules you need to remember on how to reflect over y equals x and y equals negative x. Okay? So go ahead and review that if you don't recall. Alright, these are our last 2 questions. This is how we're going to review, or we're going to review how to actually do a transformation. Obviously, this is not everything. So if you still need more practice, you can go back into your transformations unit to review this. This one wants you to rotate the rectangle 90 degrees clockwise. So what was our method on doing that? You're going to take your paper and you're going to go 90 degrees. So how many times would you turn it? Just once, and it's going clockwise. So which direction would you go? You go this way. So I obviously can't do this with the screen, but you can take your paper and you're going to turn it to the side. And then once you're there, you're going to tell me what the points are with that orientation. So if you take your packet and you turn it like this, can you write down what the points are? What's the upper left corner? Clockwise is this way. Clockwise is that way. So what's the upper left corner? Everybody should be doing
Of the
this.
new one?
Of the new shape. If you actually do the rotation, which everybody should be doing,
One,
if you actually
three.
do that,
One,
the upper left corner should be 1, 3. Bottom left corner,
1, 1.
upper right corner,
4.
4,
4, 3.
4, 3. And then the bottom right corner,
4, 2.
4, 1. So as you're looking at it like this, you want to write down those points, and then you want to put your paper back to the original orientation, and then just write those points on, or sorry, plot those points. So we had 1, 3, 1, 1, 4, 1, 2, 3, 4, 3, and 4, 1. So this is what your shape would look like after you do that rotation. Alright, and then the next one is going to be reflecting over a line. Reflect over x equals -3. Would this be a horizontal or a vertical line? It is vertical. When I say x equals, that means that's the axis that you're crossing. So if I'm crossing the x-axis, it's vertical. At what value? At -3. So you're going to go to -3 on the x-axis, and you're going to draw, that's your mirror. Your line of reflection. Now, how do I actually reflect over that? What do I do? What's the process? How? Okay. Okay, so you count how far away it is from the mirror. So like this point right here is how far? To the left, so I would go 2 to the right from the mirror, so that's this point. What about this one? Still 2 to the left, so you're going to do 2 to the right. Make sure they're lined up, they're just going in different directions. But this one, does that mean I just choose 2 points because these are the only ones that are on the left? No. You still have to reflect this one, it's just different because it's on the other side of the mirror. So if this one's 1 to the right, how would I reflect that one? 1 to the left. So it doesn't matter if your mirror is going through the shape or not, just make sure that you move the points to the other side of the original. So they are going to be overlapping, that's okay. That's what your reflection will look like. Alright?